Hello everyone, good morning. In today's class, we are going to talk about Kubernetes networking. Before we start this Kubernetes network, you should know some basic points. Okay, first point, this is a container. Containers have ports, but not IP addresses. Containers have ports, but not IP addresses. Second, container. This is pod. Outer cover of container is pod. Pods have IP addresses, but not ports. Very, very important. Mostly people get confused here. Containers have ports, but not IP addresses. Pods have IP addresses, but not ports. Remember this. Okay. Third point, Kubernetes cluster means what? Master and worker combination. Either you can call workers or nodes. You must be thinking, Sai, as of now, we are discussing everything in single node. Right. Yeah. As of now, we are discussing everything in single node. But later on, at the end of Kubernetes, we will be having multi-node setup like this. So whatever manifest that we are writing right now will remain same. Right now, what we are doing, we are writing manifests. We are applying locally. Everything is happening on the same machine. Pods are getting created. Inside containers are getting created. Later on, the same manifests only we are going to apply here in master. So those will be executed in nodes. On top of nodes, pods and containers will be created. Okay. So for that, first we should understand these manifests. That's why we are learning these manifests. Later on, we will be having multi-node setup. So here Kubernetes cluster means master and node combination. Understood? Coming to next one. See, let's say this is one pod. This is one pod. Let's say I have two containers. Inside these containers, some website is running. Website is there. Assume that two different websites are running. You are opening port 80 here. Here also you are opening port 80. You should not do. Inside a pod, two containers cannot have same ports open. I'm repeating. Inside a pod, you have two containers, fine. Two or more in number of containers, doesn't matter. But each container should have different ports open. Why? Because generally what we do, we use pod IP address to access application which is running inside containers. So what we do, let's say IP colon 80, pod IP colon container port we use to access application. When you give 80, so your request should go to container A or container B, which one? So there's a confusion, correct or not? That's why you cannot have same port opened for multiple containers. You are taking here 80, you take one another port, let's say 81. This is fine. When you use IP, pod IP colon container port 80, then your request will go to container A. If you give IP address colon 81, then your request will go to container B. Got it? Very, very important point, guys. Remember. And the fifth point, local host means what? Local host or pod IP, both are same here. Inside pod, remember that. Inside pod, instead of using pod IP address, you can use local host as well. Okay. So remember these 5 points. Now let's get into networking. Okay. First, we are going to see container to container communication. Containers within a pod can able to communicate with each other automatically. Let's say this is my pod. Inside pod, I have two containers. This is one container, this is another container. Let's say container 1, C1. This is C2. You are in one container. You want to access the application which is running in another container. Yes, you can very well do that. Let's say you open the port. Let's say in container 2, website is running. Website. You want to access that website. Yes, very well. You open port 80. From here, you can able to access. Okay, you are in one container. You can access application running in another container. So it happens automatically. You don't need any external network. For example, you are in one room. This is your brother. This is you. C1 is your brother. C2 is you. So pod is one room. Inside one room, you and your brother. So if you want to talk to your brother, you don't need any electronic device. Correct or not? Directly you can talk to him. Understanding, right? Inside one room, if you want to talk to your brother, you don't need any external electronic gadget. Correct or not? You can directly talk to him. Correct? Here also, inside a pod, between containers, communication happens automatically. That's a default behavior. So inside a pod, containers can able to communicate with each other automatically. You don't need any external network device. Clear? Okay. So let's do it now. Let me show you, then you'll understand. Let me go to AWS account. Now login. Next. Sign in. Enter MFA 78368. That's it. Now go to EC2. Instances. Select your instance. And here, instance state. Start. Connect. Username, enter DNS name. Sessions, new session, SSH, minikube. Okay. Okay, that's it. Now, clear the screen, sudo, minus. So we have to start minikube, start, -- force. Let's wait. Once it is ready, then we'll proceed further. Clear the screen. So what I'll do, I'll create one simple manifest. I'll create one manifest in which I'm going to mention as one pod. Inside, I'll keep two containers. And after that, let's see whether we can able to, a person inside container one can able to access the application which is in container two or not. Okay, that is what we are going to see. So let's do it. VI, I'm giving name as interpod. Interpod. This is just a manifest. Whatever name you want, you can use. That is your wish. Just I'm giving interpod.yml. Okay. Now let's try to understand what is happening here. Kind, I'm creating pod object only. Pod object. And you know that comes under version V1. Already we have discussed in previous classes. And I'm giving a name to that pod as test pod. The name of pod is going to be test pod. Fine. Inside pod, I'm creating two containers. See, container 1 and container 2. So for better clarity, what you can do, you can give spaces, blank lines, so that there won't be any confusion. Got it? First container C00, second container C01. Pod name is test pod. So let's give these names. So this is test pod. First container C00. Second container is C01. Okay, fine. Now, first container I'm creating with Ubuntu image. Inside just I'm running hello Sai. Hello Sai will be printed. Correct? That already you know. We have seen many times. See, hello Sai will be printed after every 5 seconds. First hello Sai will be printed, then it takes a break of 5 seconds. Again hello Sai, again break, again hello Sai. That's a continuous loop. So in container 2, C01, this container I'm creating from HTTPD image, directly HTTPD image. Okay. So as you know that if a machine has, if I take HTTPD image means what? What is happening here? Already here web package will be there, correct? HTTPD, and that service would be running, correct? Service. Now only thing that we need to do is we need to create a file. That's what index file. We need to put some content. Correct? So here web package is there. Service must be already running after creating container. Now, only thing is that we need to create a file index.html so that whatever content we keep, that will be displayed to customers. Correct? Let's say if file is not there, then by default, what content will be displayed? It shows as it works. Remember, it works. In browser, it displays this particular message. What is the meaning of it? Meaning is you have to understand that, okay, web package is there, service is running. But the thing is that file is missing. Understood? Fine. So that means if you can able to see it works means what? Things are working fine. Only thing is that you have to keep the file. That's it. Fine. So here I am creating this container with HTTPD image. And obviously, if you want to access, you need to open port 80, correct or not? Already these, basics earlier we have covered already all of them when we were discussing Apache web server. So here we have to open container port 80. So here ports, colon. These are fixed. You have to remember it. Container, port, this is fixing. Here open the port number 80 because you know that web container, website we access through port 80 only. That means here port 80. Here that's what HTTPD is running. Clear? So we have opened port 80. Right. That's it. Now what we'll do, we'll go inside this container and we'll try to access this HTTPD. So if we can able to access, then we can come to a conclusion that yes, from sitting in one container, we can able to access the application in another container. Correct? That would be the conclusion. Yes. Now let's apply kubectl apply -f interpod.yml. That's it. So we have created pod. Now verify kubectl get pods. Yes, you can see they are working. I mean, not ready yet completely, but still, see, contents are getting created inside. Out of 2 containers, 0 is ready. Means both containers are not ready yet. They are under progress, being created. Let's verify again. Both are running fine. You can see out of 2 containers, both containers are running fine inside this pod. Okay. Or else you can simply use kubectl get all. If apart from pods, if we have any other information, that also will be displayed. Now, let's go inside one container. You know already that command earlier we have seen. How to go inside container? kubectl exec, and we have to give the pod name. What is the pod name? Test pod. Test pod -it. See, if you don't give any container name, I mean, if you have only one container, by default, you go inside the container. You don't have to mention container name. But if you have multiple containers, then you have to mention container name. I'm repeating. If a pod is having only one container, then while going inside the container, you don't have to mention the container name because there is only one container. Even if you don't mention the name, by default, you go inside that container only. But if a pod having multiple containers, you have to mention container name explicitly. So -it, then -c, container, C00. That means I want to go inside this particular container. Okay, C00. Then -, then /bin/bash. Okay, again, remaining things are pretty same what we covered already. Okay, so I would like to go inside this pod in this particular container. Now enter. We are in this particular container right now. Now from here, I would like to access this HTTPD, this application. Okay. Remember one thing, guys. In browser, if you want to access, we use IP address. In browser, if you want to see web content, generally we use IP address. Correct? But from command line, if you want to access website, from command line, we use curl command. Curl and IP address. So in browser, whatever content you see, right? That same content you can see here. If you are seeing that content here, means yes, website also will work. Okay, in website also you can able to see. So in command line, if you want to access, we use curl command. Web content, if you want to access through command line, we use curl command. Remember that. Curl is one of the packages. So sometimes you may or may not find this curl package. If curl package is not there, you can't use curl command. So what we do, since it is Ubuntu machine, first let's update and we'll install curl package. Okay. Apt update. Let's update my container. I'm updating this particular container. Okay. Then I'm going to install curl package. Apt install curl. Apt install curl. Yes. Press Y to proceed. Okay, that's it. We have installed curl. Now what you do, you use curl. This pod IP address :port 80. Pod is having its IP address, right? So curl pod IP address :port 80. Okay. What is pod IP? How to verify? Or else you can use localhost as well. Okay, you can use localhost. First, let me show you by running localhost. Then I'll show you pod IP as well. localhost. I told you, right, inside a pod, when you use localhost inside pod means you could be inside container as well. So inside a pod, if you are running localhost means what? The meaning is pod IP. Either you can use pod IP or localhost. Already we have discussed, right? So localhost colon 80. 80 means this is a port only we have opened, right? Now when you press enter, you should be able to see it works. Right? You can say HTML content. The same content you can able to see in browser. Right? That means we can able to access the application. If you keep any index file, if you have any, if that has any content, that content will be displayed over here. Got it? That is so. Now you must be getting one doubt. That's why, let's say, see here we have one more container, C02. If that container also has port 80 opened, port 80, here also one application is running. Then if I use localhost colon 80, then my request should go to container 01 or container 02 because I'm not mentioning any container details. Curl localhost. Localhost means what? Pod IP. Colon just I'm giving port only. So, but two containers having that port opened. Then my request from C00 will go to C01 or C02. To which container? That is what I have explained at the beginning. You cannot have multiple containers inside one pod having the same port opened. You cannot have. So it's a conflict. It's a conflict. You cannot have. You can have, yes, 81. You can give any other port. Let's say 81. This is fine. So here when we use 80, then the request will go to C01. Here if you give 81, localhost colon 81, then the request will go inside C02 because here 81. Got it? So that is how things work. Remember that. So things are working fine, right? See, I'm able to access means things are working fine. So right now I'm here. From here we are accessing the application inside C01. That means conclusion is what? Summary is what? Inside one pod, two containers can able to communicate with each other automatically. Not only two, inside one pod, containers can able to communicate with each other automatically. You don't need any external network device or external network setup. Okay. Now let's come out of it, exit. Exit. And let me delete this particular pod. We don't need this one anymore. Kubectl -f, kubectl delete -f, interpod.yml. That's it.